I guess before you start, does anyone have any pressing questions they want to discuss before I get on my,
The hug they want to talk about.
yeah. any-
I think Hug was great event. Whatever it had its own issues, but it was so good to see everyone in person and have
Oh
discussion.
yeah.
And then I changed discussion with you and Quincy. It was like old good times.
Yeah, I really enjoyed the going to the hug meetings. It's nice to see everybody that uses HDF5 and
Yeah.
people who do all their good stuff with all the software that I throw together while supervising my small people. Nice to see. Look forward to seeing people in Europe.
All right, so I think I'll just go on.
Uh-huh.
Yeah.
So this is basically a follow-up to the last call of doctor I did, which focused on the h5fuse script. And just a reminder of what it is. It's just a utility that uses DD, and you can see the output here of combining these subfiles into a single HDF5 file. And it's installed under the bin directory if you're interested in using it, usually, well, the newer. So I've now updated to a new application. So last time I showed X MPM using h5fuse, and now I have a new example that's in Cabana itself. I mean, X MPM uses Cabana, but this is the example that just uses Cabana. So I have the link up here, so it's in their repo. Well, I have a PR that's from my repo into theirs. So hopefully this will be accepted pretty soon, within a week or so, into their final repo. But it'll end up in the example core, and then they have a 13 HDF5 advanced example, and this is the example. So what I'll show in the next few slides are just for if you want to see I've skipped a few lines, of course, from just to highlight what it's doing. But if you want to look at the whole example in its context, just look. You can look there at this link here, and let me just in case I can. Well, I'll copy it to the chat. So as before, we start with, let me go back here. Okay, so we start the main, so in this example, it starts the main time step loop. So it loops over the steps, and then it has the frequency of the output. And then this calls this HDF5 particle output, just writes that time step. So in this step, it will write all the subfiles. And for all this example, I'm writing to the node local storage on Frontier. You can think of that. So in the results, you can write it either place, but for this, I'm writing to the node local storage. And then I stat the file to see if the h5fuse. I assume that script is in where the executable is, where the files are to be. Let me see where the executable is. And then I've configured whether to see if subfiling was actually used, because if it doesn't, and I skipped a step. And then, as I mentioned last time, this is how you split the communicator to be one node per, or one rank per node. And so the return rank will be so that the communicator for that, each node will be the shared memory communicator. And then the rank inside that communicator is gotten from the MPI call. Next, we use that rank then will only execute the h5fuse. So what's different now is I keep track of how many, so I fork the process, but then I also keep track of how many processes I've forked, and you'll see why later. And then rank number 0, or this PID, if it's successful, then it will find a subfiling configuration file, and it's the same as it was I showed before, and you can look at the details. That's not really that important. And then it sets up the arguments to use for h5fuse, and then as it was before, it just removes the subfiles when it's done processing it. And then this is execution of that fuse. And then I free the communicator. So this happens all within a time step. And here we just increases the time step. So after all the time steps done, the last time I was waiting within a time step, and now since I keep track of how many processes I've forked, now before I exit, the program exits, I make sure that all those processes have been complete. And I just do that by looping over the number of forks. And then I wait for the PID to finish. And I loop over all the forks to make sure they're all done. And I've looked at at least the ones on Frontier, and they're pretty much done right away. So this wait doesn't really, it's just to eliminate zombie processes if there are any. So that's what's different than what I showed last time. So this is the results for using H5. It's updated from the last time. So it's doing 1,024 subfiles, it's around a terabyte. And so this is the total time it takes for the whole simulation. It's not just IO. So this is without fusing the files to no local storage. And this is with fusing the no local storage. And this is just writing to the Leicester file system as a single shared file. So both, you still see a little bit increase, which I'm still working on, but it wasn't as bad as last time. So it is hiding a lot of the fusing happening. And then I also wanted to see what the difference was between, in Frontier, you have the option of using progressive file layout. So basically you don't have to set up the stripe count and stripe size ahead of time. It automatically adjusts those parameters as the file gets written. The other option is to set those luster stripe beforehand manually. So for this case, I used a stripe count of 64 and a stripe size of 16 megabytes. And I ran it 5 times. And so this is the first number is the run number. The second is the time step that it outputs. So it outputs 4 time steps. And the spread here is from each node. So it's how long each node took to complete the h5fuse command. So you can see that the progressive layout actually does very good. I was kind of surprised because currently for Frontier, we're seeing that single shared file, at least directly from HDF5, does not perform all that well. But if you compare it to so normally we've been setting on Frontier the stripe size and stripe count manually and not using progressive because, I mean, but in this case, it actually, for the most part, performs better than setting it manually, which is kind of counter to what we have been seeing with HDF5. So this gives you an idea. So I guess if you're doing this currently, you probably don't really have to you can use the progressive file layout feature on Leicester, and it shouldn't hurt your performance all that much. But the spread is pretty large. So some take 5 seconds to complete the fuse script, and some take 35 seconds. So it's still large, but even the trend is the worst case is still not as bad as the other one. So that's just an update of using. There's still some work to do. I don't think I'm getting the best performance out of no local storage. If I computed the IO time step, and that's including HDF5, so that's everything. It's not just the MPI call, the write call only. I was getting about 250 megabytes per second to no local storage, which is pretty bad. But if I just do like a DD command to no local storage, I can get over 2 gigabytes per second. So I have to see if it's the MPI write call that's actually taking is not, I mean, it should be fairly fast. So I have to time the actual call that does the writing. Well, in this case, for subfiling, it would be the POSIX write command. So any questions about this? Let me copy the link in case you want to look at the.
So Scott, I missed the last meeting, so I maybe I'm missing pieces. What you're talking about is you fusing the file, creating one shared file, HDFI file within the application, right?
Correct.
That's what.
Yes. The
Uh-huh.
other option would be to submit, so you run your job completely and you get all these subfiles,
Uh-huh.
and then you can run another JS run or S run command with only running one node per, well, you can do more than one node if you want, but using one process per node and then calling the h5fuse command as the argument. But that means, yeah.
Uh-huh. Have you tried that parallel tool that we have that spawns other? It uses MPI to spawn other HDF5 tools, command line tools. I forgot the name of it.
Yeah, I looked at it. Yeah, but this is much more, it's simpler, I think.
Okay.
Not that.
I
Yeah.
see. Okay. Uh-huh. Thank you.
Yeah, I haven't played around with using more, well, increasing the number of subfiling threads. Right now it's default to 4. I could increase that and play around. And I also haven't played around with using more than one process per node to do subfiles. Because in the past that hasn't proved beneficial, but maybe it would here. Any other questions?
You know my request for diffuse. That's it.
But yeah, but it'd be the Leicester, right? Because you couldn't do it unless you submit a job to diffuse it to a no local storage to read it from, which I don't know if that would have any benefit of doing that.
Just if you want to restart your application, right, using some file, you
An HDF5 file is already there.
yeah, you have a HDFI file that is input to application, and
Mhm.
you want to use subfiling to.
But I'm not sure that you'd have to still split that file, and I'm not sure that would save you the time of just reading it from Leicester. Because you'd have to split it and then read it, right? So it's 2 steps. And you can't really hide that because you obviously need to read that before you have to complete the fuse before you start reading it.
Right.
So,
right.
I mean, using the data.
Right. But then you can modify it, right? And not rewrite the whole thing.
Right. Yeah.
Mhm.
Anything
Once
else
again,
just in general?
the
Huh?
use case should be identified first. I just asking, but maybe there's no use case for it. So just take it as a use case. We need to talk to applications if it's needed.
Yeah, we haven't got a lot of feedback from applications using subfiling. So, um, maybe once it starts to, I don't know. And I do have to look at larger. I mean, 1024. I think in Frontier I can go to 9,000 nodes for the whole machine. So at least I can try it with half to see if it's because subfiling really does shine when you start to get really large. I mean, 1024 is not nothing, but it's nothing. It's not the close to the whole machine.
Right, and having paper published will definitely get attention because now it's hard to find.
Mm-hmm.
Mhm.
Yeah, we just have a white paper that
Mhm.
it was basically ECP reports.
Right, but publish it, it will
Mm-hmm.
happen. Mhm. And with big application, as you said, yes.
I think the Parthenon people have had some interest in using subfiling, so I think they're going to try it out. So we'll see. Danny, do you have anything you want to discuss or?
I didn't have anything too specific. Just that we're putting together 114.3, 114.2 is out. I think the news release, the newsletter should go out in the next day or two. We're just
Oh, Lori, there was a press release, so congratulations on your release.
Oh, okay, so it went out. Okay, great. Yeah, sorry.
1.4 out.
Yeah, and then 114.3, we're releasing. That's gonna be the last one for the E4S final ECP exascale computing project software release. And so we're getting the last bits of that. One of the things on the CVE front, that one should be CVE free. I found the last of the Talus files buried in Jira, and so I put those in the CVE repository and fixed one of the issues in there that had not really regressed, but we'd allowed an assert to trigger. And then so I fixed that. And then there's one more CVE issue that should have a fix this week. And then that's it. And then we should have a fix in for everything, except for the H5 GIF issues, which we don't build the GIF tools by default anymore. So right now, that's just we turn them off. I might fix those in the future. But for right now, I'm more concerned with the library ones rather than something that just affects a poorly programmed tool. And
CVE GIF was in GIF library. It was not HDF5 library, as I recall. It was
if I remember correctly, all three of those are problems in the GIF tool itself. That the GIF tool is poorly programmed. It doesn't check very carefully. Like there's a bunch of there's a file format, and it's kind of the same thing that you can do with HDF5 is you can lie to it and it'll do dumb stuff. So so if it's a misparsed GIF file, it can create garbage. So I haven't had time to go through and fix those because I haven't prioritized that highly because they don't seem to be that important to anyone anymore. GIFs just aren't that popular. And so and we don't build them by default. And it's easy to switch off. So we don't worry about it too much, but I will try to fix those at some point. Or we'll remove those out of the library to a new repository, in which case I'll probably still try to fix them. Let's see what else. Oh, and actually there's one extra one where somebody reported an issue, but they never gave us a POC file. The proof of concept file was just a zip file with a text document in it, but they did describe what the problem is. So I'll probably try to create a reproducer for that. But yeah, for all the ones where there is a proof of concept file, we're good. So I'm pretty excited about that. That's pretty much all I have right now. Oh, we got a comment here in the chat. It's in the chat. Oh, that's just you. Okay.
Yeah. Yep. Okay. Anything else or?
Any questions?
I just wondering about workshop. Do you guys think it would be a good idea to have kind of feedback survey? What went like postmortem from the users, get feedback, what they want to see in the future, what was good, what was not as good. Just few questions, like 2-3 questions.
Yeah, I think so.
Maybe Lori can put something. It will be good to have feedback.
Yeah.
Mm-hmm.
Yeah, I would like to hear from people what they thought was good and what was not.
Also, there was a report about failures on AMR, on what ARM, not AMR. I was in different world. Yes, ARM architecture, right?
Yes.
And I'm wondering if it's this cross compilation that everyone tells that it's resolved.
Well, I mean, it's not resolved in released versions of the library,
Oh,
right? Because I can't move that fix that they're getting rid of H5 detect. I can't move that to 114 until I fix the Nag Fortran bug.
Oh, I see. Okay.
So it's not at 114 yet, because otherwise Nag Fortran breaks.
I see. It's in develop. Okay.
Yeah, develop only.
Mm-hmm.
So I'm excited to move it. I'm very keen on moving that hopefully soon.
And there was also a report from H5Pi guys. They once again see what I think what they're doing. They see essentially corrupted file. I think they're running Swimmer on an FS system.
Oh yeah, there's some there were some guys who were at, I can't remember the name of their company. Rogue Research, maybe it was them. There was somebody, and they had some ideas for NFS detection that they thought would work well, and I thought there was also some sort of like hacky flush thing that they were going to implement that could potentially allow it to work, um, be less problematic on NFS. But we had like a meeting at the beginning of the summer, maybe in May, and they said they were going to create a PR and start coming to the Thursday meetings, and they didn't. And so I'm going to ping them again and see what they got. Because just having NFS detection to yell at people based on the
Right, before they start
file
corrupting
management.
data. Yeah,
Yeah.
right, right.
So if we try to set swimmer, it'll complain.
You simply do not know, so you have to, yeah, and it has to be. Still, I think we need to solve this problem in the right way and just, finish development of VFD Swimmer that solves this problem.
Well, yes, but I mean, still, legacy swimmer is still gonna be around for a while,
Right, right.
right? So we'll have
And
to.
there, yes, all kind of remedies are needed. Yes, I agree.
How does VFD Swimmer fix it? I thought it was a POSIX compliance thing issue. It's not.
No, VFD Swimmer doesn't need POSIX compliance because it takes snapshots of metadata. And reader reads from that snapshot. It's not reading from the file that may not have consistent metadata.
So it
Oh, I
just
see.
cycles snapshots, so it kind of gets away with it.
Oh, okay. That's clever.
And it can be put on different device. So because the question was like, if I corrupt my metadata, yeah, if you corrupt your first metadata journal file, you're doomed. But make backup of your file and put metadata on some other device, not on the same device where your current file is, because it's possible. And with the network file system, there should be, I believe, there is some process that helps with that, and it's implemented, but it was never tested. It's still some work needs to be done.
Yeah. Yeah, it's my cue to start bringing some of that stuff over, like the page buffering changes that John made. Like Alexander is starting to push on the edges of the page buffering stuff because of the needs of the cloud optimized files. So I have to go look at that code anyway. So while I was in there, I was gonna compare and contrast and see what John had done, and hopefully I was hoping to bring his stuff over earlier under the VFD Smart project. But John said that it would be a trickier process because he'd added a bunch of VFD Swimmer specific stuff. And I didn't want to drag that over and have it untested and just be basically dead code. So I don't know, we'll see.
Oh, Greg has question in the chat. Yeah, we just need to detect that a file is located on NFS system and it cannot be open in swimmer mode for the legacy swimmer.
Yeah, you just basically have to stat the file and then look at the magic number that you get back, and then we just have to have some checks for the common network file systems that we know about. It's not super difficult. Like I was gonna do like NFS, and I don't even know if people use AFS anymore. But the other one is SMB. And then we have to do the same thing on Windows so that we can detect shares on Windows because they won't have that stat field. So
thank you, Greg. So Greg will share the code, right?
yeah, if you have that code, if you could send me like a snippet, that'd be cool. Yeah. The hard thing is just trying to make it work everywhere. I'm always hesitant to. I like to solve stuff comprehensively. I'm not a. It could be otherwise you wind up with like Windows being a second class citizen because we solve the thing on the platform we know best, and everybody's like, Windows, we don't care. And so
No, those people are on Windows, Python people, so we have to solve it for
yeah,
Windows.
they care there too. I think that's actually where it gets caught. I mean, well, I feel like there's two places where the swimmer stuff fails when we have problems. One is login nodes, right, which seem to be commonly used NFS. And then when people are building, then the parallel tests, I'm sorry, the swimmer tests fail, and even though they're not using swimmer. And then yeah, Windows on Windows shares. That people don't understand that that shared thing that IT set up for them is actually basically an NFS drive or a Windows server share. Then those are network file systems that don't guarantee ordering.
Then, but I thought the problem was solved because, and Larry will know, are we running tests, regression tests, swimmer tests when we're using NFS system? I don't
No, we
think
run it locally.
by forcing it to run locally or we're detecting. Because I think that we had this conversation like 5 years ago, right?
Yeah, I'm almost positive we just run it in temp.
Right.
Some local thing.
Yeah, we always run it on local machine.
So
Yeah.
we don't have automatic detection. That's what you're
No.
saying.
We do
No,
not.
Okay. But because I thought we put it in the tests, not in the code, but in the tests that we would determine where it runs, and we're not running there.
No, we didn't do that yet.
right.
So
With the Unix tests, we set them all up on local machines. And
I
if,
see.
if we accidentally fail to do that, we have problems.
Yeah, they'll eventually fail.
Okay, well, I guess we're out of time.
All right.
Yep, thanks for and Garrett's doing the next call the doctor. So
Oh.
next week.
Thank you.
Yeah. All right, bye.
Bye, one.
Bye bye.